Okay, lesson 7 here, magnetic forces on current. So there's a video here, force on a current carrying wire, that's on the website for you to look at. Alright, so as we've just found out, that if we have a wire which has a current flowing in it, and that's flowing up that way, then we'll get a magnetic field that goes around that wire, whoops, in that direction. So if we then put it in a magnetic field, and so the magnetic field's going this way, then you've got the magnetic field on the wire, the blue one, and the magnetic field on the that it's in, the green one, and they're going to interact with each other. So when they interact with each other, there's going to be a force and some movement because you've got these fields. All right, and so you would have seen that in the video when you watch the video. When they turn the current on, you see the wire jumping around. All right, so clearly it moves. So the question is, how do we actually determine that? And so it's the right hand push rule. So right hand, so it works with the right hand only. So we've got our right hand, and it says, so to do that, you point your direct fingers in the direction of the field. So if I've got a field pushing going this way, so I've got a going this way, and then so my fingers have got to point that way, and if I have a current, let's say the current's going up that way, so fingers in the direction of the so here's my fingers pointing in the direction of the magnetic field, the thumb in the direction of the current. So if my fingers are pointing there, to push my thumb in the direction of the current. Remember, this is the right hand rule. So my thumb in the direction of the current. My finger on there, so we've got the right number. So the only way with your right hand that you can put your fingers pointing to the right there and your thumb pointing up is if your palm faces out. So what we've got is the palm out here. So your palm is facing out. And so the push part of it comes because if we pushed, we would be pushing with our palm, and so the direction of this one would be palm pushes out of page. Alright, so that's the right hand push rule. Fingers in direction of field, thumb in direction of current, the palm pushes in the direction of the force. Alright, so there's a few things that we can think about here that this force might depend on. So firstly, there's a current, so the size of that. There's a field, so the strength of our magnetic field. The length of, well, how big the magnetic field, in other words, what the length of wire inside the magnetic field. There's that one there, but if our magnetic field was longer, there'd be more wire in that magnetic field. And of course, if there was more wires, so there was a coil, for example, rather than just a single wire, then it's going to be multiplied for each wire. Alright, so when you take all of that into account, you get the formula. And the formula is that the force is equal to N the number of wires, I the current, L the length of the wire in the field, and B the magnetic field. Alright, so that's the number of wires. This is the current. This is the length of the wire. Now, there is another factor, but we don't have to. It's in the notes there. It's just down as a little a note that the angle between the field, so this angle in here makes a difference. But in this course, we only need to look at when they're perpendicular, like the diagram I've got here, or if they're parallel. And if the field and there's the field and the current, there's the current, are parallel, then you actually, in this case, the force will be equal to 0 Newton if the field and the current are in the same direction. Alright, let's have a look at an example. It's only a short one, this one. So here's our example. Wire is carrying a current of 3.4 amps placed at right angles to a field of strength 0.2 Tesla. Calculate the magnitude and direction of the force on a wire of length 0.8 metres. Right, it says a wire, so that means that N equals 1. So F equals N I L B. So the force is equal to 1 times the current 3.4 times the length of the thing in there, which is 0.8 of a metre, times the magnetic field, which is 0.2 Tesla. And you stick all of that in your calculator and you get 0.54 Newton. Alright, the next thing tells you to find the direction. So the direction, remember, our fingers go in the direction of the field and our thumb goes in the direction of the current. Now, with your right hand, the only way you can do that is if the back of your hand is showing up. So there's our great artwork here. Don't be too jealous. There we go, fingernails and knuckles. So our palm is pointing into the page, so our direction is into page. Alright, and into page, out of page, up, down, or they're all valid things that we look at. Alright, so in your notes there, now there's some examples for you to do. So they're all past exam questions. There's about 4 of those. So that's what you now need to do. Don't forget to ask questions, anything you didn't understand, and watch the video on the website.